Hey guys, I hope you had a great weekend. I want to go over some stuff that we did Friday, just rehashing some of the stuff to make sure that we remember and we understand what's going on. Okay? When we're solving a system of equations with three variables and all three of the variables are there, like as in this case on this worksheet, remember what we have to do is try to eliminate one of the variables. Okay? So we're going to start off by doing number 1. Okay, we'll do number 1 together. So if we're trying to decide which variable to eliminate, 2, 6, and 4, those are pretty good to choose because we have a 2 and a 4. We can multiply that one by -2 to make the x's cancel out. And we have a 6 and a 2. So we can multiply this middle one by -3 to make the x's cancel out. So that's one choice. Another choice would be the y's, especially when you have a 1. That's always really nice. Okay? Because even though we have a 1 and a 5 and those two really aren't related, we've got the 1. So we could multiply this by a -3 and combine it with the middle equation and that y would cancel to 0. We could multiply this one by a -5 and combine it with the bottom equation and that would go to 0. Okay? 3, 4, and 2, while those are close numbers, they're really not related. So it would probably be best on number 1 to either eliminate the x's or the y's. Okay, I'm going to eliminate the y's. If you want to do x's, you go right ahead. Okay, so I'm going to write down the first equation, 6x plus y plus 3z equals 48. And I'm going to write down the second equation, 2x plus 3y plus 4z equals 50. Okay, and I'm going to eliminate the y's. And the way I'm going to eliminate the y's is I'm going to multiply the top equation by a -3. Okay? When I multiply the top equation by -3, I get -18x minus 3y minus 9z equals, and 48 times 3 is -144. Okay? Now I'm going to rewrite my second equation right over here. 2x plus 3y plus 4z equals 50. And I'm going to combine these two equations. Okay? So I get -16x, that's 0, and -5z equals -94. Okay? So I have one equation with x and z. Hopefully you remember from Friday that if I have one equation with x and z, I need another equation with x and z. So I've got to go back to my original problems. I'm going to just ignore this one for a minute. Okay? Going back to my original problems, first I used 1 and 2, the first equation and the second equation. Now I'm going to use the first equation and the last equation to eliminate y again. So I'm going to write the first equation, 6x plus y plus 3z equals 48. And I'm going to rewrite the last equation, 4x plus 5y plus 2z equals 58. Okay? Now, in order to eliminate this y, I've got to multiply the entire equation by a -5. Because that'll give me a -5y and a positive 5y, and that's what I need, opposites. So I get -30x minus 5y minus 15z equals 48 times 5. Whoa, 48 times 5. 240. And it is a negative, right? -240. Alright? Then I'm going to rewrite my second equation right here and get 4x plus 5y plus 2z equals 58. And when I combine those two equations, I get -26x, that's 0, minus 13z equals -182. Okay? So now I have this equation with x and z, and I have this equation with x and z. Alright? So that becomes its own little mini system inside the problem so that I can eliminate still another variable and be able to finally solve for one of them. So I'm just rewriting these two equations right here. so they're easily accessible. Okay? Now between these two sets, either the x or the z, which variable do you think we should eliminate? Right, the z's. So I'm going to multiply the top by 13 and the bottom by 5, negative 5. Okay? Because again, I need them to be opposite signs. Okay? When I multiply the top equation by 13, I get 208x, negative 208x, minus 65z equals negative 1,222. Okay? Now when I multiply the bottom equation by negative 5, I get 26 times 5 is 130x, and that's a positive because I have a negative 5 times a negative 26 plus 65z, 182 times 5, equals 910. Again, it's a positive because it's a negative 5 times a negative 182. Okay? When I combine these two equations, I get 78x, that's 0, equals 312. And when I divide both sides by 78, I get x equals 4. Now that I know that x equals 4, I can go back up to one of my starred equation and substitute x equals 4 into one of those equations. I'd probably choose the top one just because that multiplier is smaller, but it really doesn't make a difference. So negative 16x, except I know x is 4, minus 5z equals negative 94. So 16 times 4 is 64. Minus 5z equals negative 94. Oh, and this is a negative 64, yes? Okay, so if I add 64 to both sides, I get negative 5z equals negative 30. So z equals 6. So I know x and I know z, so I need to go back to the beginning, one of my original problems, and just choose one of them. We're solving for y, so I'll probably choose the first one. And I say 6 times x, which is 4, plus y, plus 3 times z, which is 6, equals 48. Okay, so 24 plus y plus 18 equals 48. And 24 plus 18 is 42, plus y equals 48. So when I subtract 42 from both sides, y equals 6. Since these are consecutive variables in the alphabet, I can say my answer is 4, 6, 6. Okay? If you'll turn to the back of your worksheet, Linear Systems E, I would like to do problem number 2 for you. Okay, so I did number 1 on the front. I'm going to do number 2 on the back for you. All right. Now, what do you notice about problem number 1? The first equation in problem number 2. It has 3 variables, right? What do you notice about the second equation in problem number 2? It has 3 variables. What do you notice about the third equation in problem number 2? It only has 2 variables. So which variable is missing? The b. Alright? So if we can somehow use the top 2 equations and eliminate the b, I will have another equation with v and y, and that is what I need. Okay? So I'm going to write down the top 2 equations. 4b plus 4v minus 6y equals negative 20. I also have the second equation, which is negative 4b minus 4v plus y equals 0. Now, watch what happens. Remember I said I'm going to try to eliminate the b's? Well, notice the b's were already opposite signs of each other. Okay, so let's just go ahead and combine these two equations just as they are. 4b and a negative 4b, that's a 0. 4v and negative 4v is also a 0. So I have negative 6y and positive 1y, which gives me negative 5y. I have negative 20 and 0, which is negative 20, so y equals 4. So I can go back over here to my original equations and look at the third equation. It has only two variables, and I know one of those two variables, y is 4. So I can rewrite that equation to solve for v this time. So negative 3v minus y, which is 4, equals a negative 13. So negative 3v minus 4 equals negative 13. If I add 4 to both sides, I get negative 3v equals negative 9. So v equals 3. And if I know y and I know v, I can use one of the first two equations to solve for b. So I'm going to use the first equation. So 4b plus 4 times v, which is 3, minus 6y, and y is 4, equals a negative 20. Okay? So 4b plus 12 minus 24 equals negative 20. So positive 12 and negative 24 is a negative 12. So 4b minus 12 equals negative 20. So if I add 12 to both sides, I get 4b equals negative 8. So b equals negative 2. Okay? Not consecutive letters in the alphabet, so I just need to list them. B is negative 2, v is 3, and y is 4. And that's your answer. Okay? You have, let's see, I did one on the front, one on the front and one on the back for you. So you have 7 on the front and 7 on the back to choose from. So I would like you to do 3 from the front and 3 from the back. You have the rest of the period to work on this. Please use your time wisely and get it done. I will check these tomorrow. Have a good day.